So now we're going to review how to write a chemical formula when you're given the name of a binary ionic compound. And remember, binary means that there's only two elements, and ionic means that you have a metal and a nonmetal. So how do you write a chemical formula from the binary ionic name? So first of all, you take a look. Barium comes first, barium's going to be first. Second comes iodide, and therefore iodine comes second. Now iodide is an ion and it has a charge. What charge is it? Taking a look at the periodic table, you will see that iodine is in group 17, and therefore its ionic charge will be -1, whereas barium is in group number 2, so its ionic charge will be +2. So once you figure that out, then you have to realize, okay, well, how many of each do I need so that the overall compound does not have a charge? Well, barium is 2 positive, you'll need 1 of them. Iodine is 1 negative, therefore you need 2 of them, so that when you add up the charges, it all adds up to 0. So when you write out the chemical formula, you'll indicate that there's 2 iodines by writing a subscript of 2 at the bottom right corner of iodine. So here's barium iodide in the chemical formula, Ba(I2). Similarly, when you look at chromium 2 oxide, now you don't need the periodic table to figure out chromium's ionic charge. You have it already. It's 2 positive. Oxygen comes second, and since it's in group 16, it will be 2 negative. Since you have a 2 positive and a 2 negative ion, you only need 1 of each, according to the zero-sum rule, and there you get CrO, chromium 2 oxide. The same can be done with platinum 4 sulfide. Platinum's the metal, it comes first. Roman numeral 4 tells you your ionic charge is +4. Sulfur is in group 16, its ionic charge is 2 negative. Using the zero-sum rule, you realize that you need two negatives of sulfur to add up with the 1 platinum. Another way you can do this is the crisscross rule. Because platinum is 4 plus and sulfur is 2 negative, you crisscross the charges. So this charge from sulfur is being written as a subscript for platinum. The charge of platinum, just the number, not the sign, is written as a subscript for sulfur. So P2S4. But remember, this is an ionic compound. It's about the formula unit, the ratio of ions. So you reduce and you'll get the chemical formula of PTS2. Now, this is all well and good, but what about a name such like stibnous chloride? This is not IUPAC, this is the classical nomenclature system. So you'll have to take a look at your periodic table. So taking a look at the periodic table, you realize that stibnous is actually antimony, and there's 2 possible ionic charges. I know this is a little blurry, but you'll see on your own that the 2 possible charges are +3 and +5. So, because it's the us ending, we know it's the lower number. And the lower number for the ionic charge was +3. So, therefore, you know that you have stibnous, SB, with a charge of 3 positive, and chloride, Cl, and it's group 17, so its charge is 1 negative. You're going to crisscross the charges, and you'll end up with a chemical formula of SbCl3. You could also use the zero-sum rule. If stibnous has a charge of 3 positive, how many -1 chlorines do you need? If each -1 chlorine is -1, then that means you need 3 of them, which you indicate as a subscript beside the chlorine.